we are, so we'll be, so the question that we had earlier that we don't know if the birds are starting from this to this, or going from this to this, or they're starting from here and going to here. So next what we are going to do is we are going to plot or the start and end journey of a bird. And that would give us the answer to this question. And so the next thing that we do is we define the paths, we define the starting points, and this has already been done. And the next thing that we have to do is we have to define the end GDF as well.
Mm-hmm.
So end GDF is going to be defined birds.group by geometry.apply.reset.index. Then you define end GDF.
Oh, make sure to change that first argument to in the geodata frame on
Um,
the, on the second line.
oh, yeah.
Otherwise, we're going to end up with some trouble.
Yeah. And this one too. And I think we should be good. Oops, maybe not. There is no end underscore df.
Oh, because your first line has ngdf. Yeah, I think that's it.
Oh, okay. Yeah.
And then, of course, we need that last line too.
So EPSG 4326.
Yep. Check. Yeah,
Yes,
there. Yeah. That'd do it.
Yeah.
Oh, let's find out. Uh-oh. Oh. We have to figure out what it is. Yeah, so I think if you look at the lambda x 0th element,
Yeah.
I'm guessing that gets the first thing.
So most probably one.
You probably want -1 to get the last thing. Oh no, you probably want -1 to get the last thing, right?
Yeah.
Yeah. Because I think if you do 1, you'll just get the second thing, and if there isn't 1, you're in trouble.
Yeah. All right. So yeah, the last thing is -1. So that gives us the correct value that it has been looking for. So where does each bird start and end its journey? So we define the path GDF, start GDF, and end GDF to visualize the path of all birds. You may also want to use the Americas geodata frame. So we'll use this first. Sorry for scrolling too much, but I think this is going to be useful. And then, oops, 1, 2, 5. Yeah. So we have this, and then we define start underscore GDF dot plot x equal to x, and then end GDF dot plot x equal to x, and then path GDF dot plot x equal to x.
There we go.
All right, so it looks like they all are starting from here. So even these ones are the starting points rather than the end points. The one in Central America. So it looks like everything is just going over here. All right.
Yeah, I guess the color of the dots may matter, or may depend on what order you plot them in, though. So if you're plotting them from end to start, or like the end first,
Yeah.
you might get something different at home. Because I think we can test that. Good
Yeah.
point. Yep, it sure enough. I'm gonna assume that this is based on storytelling with data, and that blue comes first, then orange. So.
Yeah. Yeah. So you can have. So this defines what we have been. What we have been trying to see, that they are actually going from North America to South America.
Mm-hmm.
But the first question that we came across was, there are some protected areas over here. So we want them to migrate to places which are protected. And so next we need to check if they, once they migrate, they are actually landing in those protected areas or not. Otherwise, it's just going to they're going to migrate to some place, and if it's not protected, they are not really safe when they go there. So where are the protected areas in South America? So there is a protected file path. It's shapefile, yes. And in the next course shell, you create a geodata frame protected areas containing the locations of all of the protected areas, and the corresponding shapefile is located at this location. And this is supposed to be on gpd dot from file.
I think is it read file?
Oh, maybe a read file.
I think it's read file.
Read file, and then you specify protected path, a protected file path.
Mm-hmm.
I think that's all we needed over here.
I hope so. Let's see. Yeah, it's taking a while for me to.
Yeah.
It may just be a very big file, or hard to access.
Yeah. I mean, we can test till the time it is doing. We can test that. That's what we used to do. Yeah, you define a shapefile, or actually no, this was plotting the data. So getting the file. So you get a shapefile, and then you just read file. So
oh, mine finished. Oh,
yeah,
there you go.
yes, correct.
Awesome.
So where are the protected areas in South America? So South America dot location. So when you define America's continent equal to South America, then you can just plot this. And so South America dot plot I don't know if it's going to now. I need to define some. Okay, so we do need to, so we have these protected areas that we need to plot first, and we need to plot it on top of this South America's map. But then again, we do need this blank thing again. So I'm just going to copy this again, just so that color is none. I think that's the main thing that we need. So
I agree. That'll probably get us where we want to go.
yeah, let's just try out color equal to none.
Oh yeah, of course.
So this gives us the type of graph we want. And if we just wanted to, we could have had protected areas dot plot and axis equal to max.
I ran this one already. It takes a bit because, well, you'll see why once it's done plotting.
All right, so yeah.
And there's lots of fine detailed features.
Yeah, and there are a lot of things over in the oceans. So we had a student who came up and who showed me this graph, and our assumption was, or during our discussion, that there are a lot of islands over in these places, and I think it's just covering one of the islands and the surrounding water that way. Some of them do seem very a big coverage area or big protected area. And one of the discussions that we had, I do know that in South America there is an island where you have a lot of snakes, and that comes under a protected area where nobody is allowed to go unless and until you are a researcher. There are a ton of
Hmm.
snakes in that on that island. I would definitely never go, but but yeah. So our guess was that everything that we see on the water, it's basically um, the islands that they are covering. I'm going to plot a little bigger map with the earlier values that we had.
Yeah, you'll be able to see a lot more detail.
Yeah. All right. So there are a lot of protected areas over here. This all seems Amazon,
Mm-hmm.
or a big chunk of it seems Amazon. Um, all right. I see some files. There is this island thing over here. There is this, or it looks like an island thing over here. I'm not really good with geography, so that's my assumption that these are islands and they're just protecting them. But yeah, if somebody has a better answer or explanation, or who knows this already, then just let us know. We don't have to Google, I guess. And all right, so let's plot that. So now we want to see what percentage of South America is protected. And basically, the protected area is sum of protected areas in represented areas minus rep of marine area. Oh, so which contains the total area and the total marine area respectively in square kilometers. So you subtract those two and add all of them. And then South America has this many square kilometers of protected areas. You'll use the South America's geodata frame.
Hmm.
So calculate the total area of South America by following these steps. So calculate the area of each country using the area attribute of each polygon and add up the results. The calculated area will be in units of square meters. Convert your answers to have units of square kilometers. All right. So total area is going to be uh,
Oh, that's cool. So I'm working on it right now a little bit.
yeah. So it's going to be sum of South America dot. Oh,
Okay, cool.
oh, I forget how we were calculating the areas.
Oh, it turns out it's just as straightforward as it might seem.
Yeah, it's supposed to be dot area something, right?
Yeah, it's just .geometry.area, and that's it.
Oh, okay, dot
You
geometry.
don't need to index in any special way. It's just
Yeah, it's just dot geometry dot
yeah.
area,
Yeah, I went poking around to make sure.
and you need to divide it by 10 to the power 6 or 10 to
Yeah, or 1,000 power 2 will also work. Or
yeah.
and not actually, it's not divide. It's multiply. Wait, no. Oh, sorry, it's in meters. Oh yeah, divide. Yeah, sorry. I was thinking the other way for some reason. You got it. I think that has to go outside the sum, right? Or maybe not. I don't know. What
I mean,
did
we can do it outside as well. It should be almost.
Read the warning right there tells you everything. Geometry is in a geographic CRS. Results from area are likely incorrect. So we have to convert it first. With the 2CRS thing.
Oh, okay. So dot 2 CRS, and the method of converting to CRS was EPSG equal to 3035 dot geometry dot area All right, so that should be the correct area. And so we have these many square kilometers. Yeah, so this is basically, we are doing first dot 2 CRS so that we are changing the EPSG model, and then we, whatever is the value, then we do dot geometry dot area, and that 10 to the power 6, so the to the power is 2 stars, and that gets us the total square kilometers. And now we'll just find out. So approximately 30% of South America is protected. This is not bad. So are the birds in protected areas? Create a plot that shows, or for all birds, all of the locations where they were discovered, and also plot the location of all protected areas in South America to exclude protected areas that are purely marine areas. And no landing, you can use the marine column. Okay, so we need to plot South America first, then we plot then we do the protected areas dot plot, and then we do where the birds were plotted. And next is, I think it's just birds, right? Birds, the plot.
And then yeah, it was the
Axis equal to axis.
or we can just use the Ngdf plot from earlier.
Oh yeah, that would be good too.
All about that code reuse. Oh, and the color may be an issue too, because I think both the protected areas and your bird plot use the same color.
Yeah, so color equal to red.
Red should be okay if there's a blue background, yeah. In terms of accessibility.
Yeah.
Sure. Makes sense. We can also probably make the protected areas plot somewhat transparent.
Oh yeah, that might be
that's
good
just a
too.
thought.
That might be good too.
That is really hard to tell if they are in or on the boundary of.
Yeah.
Probably because the marker size is relatively big.
Yeah.
Ah, I see. So the Ngdf plot doesn't plot nearly as much stuff as you've got.
Yeah.
Probably because the birds is all sightings, even of the same bird.
Yeah. It's
Ngdf, yeah.
There is also the marine that I could have excluded, but I left that in there as well. All right, so almost all of them, at least they look like they're very close to the protected areas, apart from this one.
I
And
made my figure bigger and my marker size smaller, and some of them are not.
no,
Yeah, this is the dangers of scatter plotting, right?
yeah. So I'm going by 100 by 100 and marker size.
Oh wow, you're gonna make a huge plot.
Yeah, marker size equal to 0.5.
That may be too small. It's like 3 pixels wide if you do that. Try one. Just try one. I think it'll be okay. I just tried 0.5 and it's way too small.
All right, let's see if this gives us a proper plot.
Oh, it may have also shrunk your map a whole bunch to fit it into the width of the notebook.
Yeah. Yeah, 100 does not seem to help.
Yeah, I did 16 by 16 and it looked okay. If you're playing along at home, this may take a bit of finagling depending on your resolution and everything.
Yeah. I mean, the general idea is it looks like a lot of birds do end up in the or close to the protected area, but not all of them, right?
Yeah, they all look like they're pretty like within, what looks to be to me about 25 miles or so, but it's really hard to tell.
Yeah. One is small too. Marker size.
We could also set well, I don't know how to do it, but we could probably set our axes limits too. I guess we could isn't it just XLM or something? Gonna zoom in on set XLM. Okay.
All right. So these are the protected areas. This one is pretty close. This one is almost there. This one is this one is almost there on the border. This one is right in between. So this one is not protected. This one is not protected. This one is very close to a protected area. This
Mm-hmm.
one has some blue protected areas over here. I'm not sure how big it is. It must be big. I mean, South America is pretty big. So, um, but yeah, it looks like most of them are going pretty close to protected area, but some might not be, which is not good if they are get in already endangered. If
Mm-hmm.
they're not getting into the protected areas, there is good chances that they might die, um, especially since they're endangered and they become a bigger target for people who want those last last living creatures of a species.
Yeah.
But yeah, that can be bad for this and this bird.
There are also some really small protected areas. So for all we know, that dot is completely covering up a protected area. I mean, it's
Yeah,
hard. It's hard to say, right?
yeah, this one is so small, and if this bird was on top of it, we would never know that.
To see it, yeah.
Yeah.
And another important thing that I discovered because I wanted to play around with it, if you go up to the protected areas plot,
The one before this.
no, back where we were, but the second line in the code, protected areas dot plot. Yeah, if you go to the right of ax equals ax and you put comma space alpha equals 0.5, you're going to find something really interesting that kind
Oh,
of messes up some of our previous work.
oh really?
Yeah, it's really interesting because apparently, depending on it may be, I don't know, but certain regions are protected multiple times.
Oh, hmm.
And you'll see what I mean in a second. It'll become, yeah, it's really obvious when you look at it this way. And so there may be multiple authorities granting protection over a certain area.
Yeah.
And because we summed area naively, it's probably not 30% that's protected. It's probably less.
Okay.
We probably double, triple, et cetera, counted some of these areas.
That is interesting.
Yeah, so I want, because I just wanted to see, if we could do a nice plot this way. And it looks nice, but then I found out, we're double counting our protected area.
That's a good catch.
So it's something to watch out for when you're playing around with data. Be careful of your plots. Plots can trick you.
Yeah. All right. So we have done the coordinate reference systems. This was the second part of the coordinate reference systems, and next time we'll continue with our geospatial analysis tutorials, and we'll be going to interactive maps. Interactive maps are also the craze nowadays, so it would be fun working with an interactive map exercise and just trying to plot it.
Cool.
All right. Thanks, everyone. Thanks for joining in. And if you guys have any questions, do send in a comment or come to our office hours or send us an email, and we would be sure to reply back to you guys with solutions for any issues that you might have, or will be available for just a general chat as well. So, and yeah, we'll talk next time. Bye.
See ya.